On May 27, 1959, 8 engineers walked out of the Sperry Rand Semiconductor division in Danbury, Connecticut, pooled what money they had, and founded a company called National Semiconductor. At its peak, it employed 40,000 people across 4 continents, manufactured more than 5,000 types of chips, and became the first semiconductor firm in history to reach $1 billion in annual sales. Its analog circuits regulated the voltage, amplified the audio, and converted the signals inside nearly every piece of consumer electronics built in the 1970s and 80s. On September 23, 2011, the name was struck from the New York Stock Exchange. Texas Instruments paid $6.5 billion in cash, absorbed the 5,000 remaining employees, and within a few years, the name National Semiconductor existed only on old data sheets and in the memories of the engineers who had built it. The company was 52 years old. A 3-pin voltage regulator it designed in 1976 is still in production today, stamped with someone else's logo. You're watching Tech District, where we take apart the companies that built the electronic world, down to the circuit board and the engineer who designed it. If that's your kind of story, subscribe and hit like, because the rise here is just as strange as the fall. To understand how National Semiconductor became what it became, you first have to understand the world it was born into. In 1959, the transistor was barely a decade old. The integrated circuit had just been conceived independently by Jack Kilby at Texas Instruments and Robert Noyce at Fairchild, and neither version had shipped in commercial volume. Most electronics still ran on vacuum tubes. A portable radio was considered a marvel. The entire American semiconductor industry generated revenues in the low hundreds of millions of dollars, and nearly all of that came from military and aerospace contracts. The idea that semiconductors would one day sit inside every appliance, every automobile, every toy, and every telephone in every home on the planet was, in 1959, not even a prediction. It was not yet imaginable. Bernard J. Rothline was a physicist working in Sperry Rand's UNIVAC division in Danbury, a quiet researcher in a field still too young to have a proper name. He was not a showman and not a salesman. He was a scientist who believed that if you built the right device, the right market would find you. In 1959, he persuaded 7 of his colleagues to leave Sperry Rand with him. Edward Clark, Joseph Gruber, Milton Schneider, Robert Hopkins, Robert Koch, Richard Rao, Arthur Seifert. 8 men, a rented facility in Danbury, Connecticut, and a conviction that they could compete in an industry already dominated by Fairchild, Texas Instruments, and the deep pockets of the United States military. Their first products were transistors and diodes. Functional, unglamorous, and essential. Sperry Rand responded to their departure by suing them for patent infringement, and that lawsuit would depress the company's stock price for the next 6 years. The founding was modest by any standard. National Semiconductor operated out of a small building in western Connecticut, 3,000 miles from the semiconductor cluster forming around Palo Alto and Mountain View. By 1961, the company had reached $3 million in annual sales. By 1965, that number had climbed to 5.3 million. It sounds like progress, but profits were actually shrinking. National earned just $238,000 in 1965, down from $362,000 the year before. The Sperry Rand lawsuit was grinding through the courts, keeping the stock price near the floor, and Rothland's insistence that discrete transistors mattered more than integrated circuits was becoming a strategic liability as the rest of the industry pivoted hard toward the chip. Rothland was eventually replaced as CEO by Jack Hegarty, and Don Lucas briefly took over as chairman. But neither man had the resources or the vision to transform a small Connecticut research outfit into a national competitor. National Semiconductor in 1965 was a company with capable engineers, decent products, and no clear path forward. That worthless stock attracted the attention of one of the most consequential investors in early Silicon Valley history. Peter J. Sprague was 27 years old, the son of the chairman of Sprague Electric Company, a prominent East Coast electronics firm. He had studied at Yale, earned a degree from MIT, and written a thesis at Columbia on manufacturing in developing nations, a subject that would prove almost eerily prophetic for the semiconductor industry. He was not a chip designer, he was a financier with family money, venture backing from a pair of West Coast investment firms, and a New York underwriter, and the audacity to bet on a company that most people had already forgotten. In 1966, Sprague used this combination of capital to take control of National Semiconductor as chairman. He understood immediately that National had technology worth preserving, but no management capable of scaling it. So Sprague did something the industry had never seen at that scale. He raided Fairchild Semiconductor, then the second largest chip maker in America, and hired away 5 of its most senior executives in a single, coordinated strike. The most important of them was Charles E. Sporck. Charlie Sporck was 39 years old, the general manager of Fairchild's entire semiconductor division, and widely regarded as the finest manufacturing executive in the business. He was not an inventor and not a circuit designer. He was a mechanical engineer from Saranac Lake, New York, a small village in the Adirondacks, where his father had driven a cab while recovering from tuberculosis, and his mother had run the family gas station. Sporck had graduated from Saranac Lake High School in 1945, studied mechanical engineering at Cornell, and spent his early career at General Electric before joining Fairchild in 1959. At Fairchild, he learned semiconductors from the ground up, running the production floor alongside Robert Noyce, Gordon Moore, Andy Grove, and Jerry Sanders, men who went on to found Intel and AMD. Sporck accepted a 50% cut in pay to become National's president in exchange for a substantial block of stock. He brought Pierre Lamond, Fairchild's best fabrication engineer. He brought Don Valentine, a marketing executive. He brought Floyd Cavami. He recruited 3 others from Texas Instruments, Perkin-Elmer, and Hewlett-Packard to form a new 8-person management team. The group was given 9.6% of National's equity. When the deal was announced, the stock jumped from around $4 to $24. Jeffrey S. Young later characterized that moment as one of the earliest acts of what would become venture capitalism in Silicon Valley. Sporck's first move was financial triage. He marked down National's entire transistor inventory by $1.5 million, forcing a $2 million loss in fiscal 1967, and refocused the company around 3 markets, specifically linear integrated circuits, digital logic, and military and industrial semiconductors. The inventory write-down was brutal but honest, and it cleared the books for what came next. In 1968, Sporck moved the entire operation from Danbury, Connecticut to Santa Clara, California. National Semiconductor was now planted in the center of what the world was beginning to call Silicon Valley. The move was only half the transformation. The other half arrived through an acquisition that brought National 2 of the most important analog engineers the industry has ever produced. In 1967, National acquired Molectro, a small Santa Clara startup founded in 1962 by 2 former Fairchild employees. Molectro was unremarkable in itself, but it employed Robert Widlar and David Talbert, a circuit designer and process engineer, who had already created the first commercially successful integrated operational amplifier, the UA702, at Fairchild. Widlar had left Fairchild over a bitter compensation dispute with Sporck himself. Now they were working for the same company again, and the results would reshape the analog semiconductor industry for the next half-century. Bob Widlar was, by every account, a genius of the first order. He was also spectacularly, unapologetically eccentric. He kept a refrigerator stocked with nothing but scotch, beer, and ice cubes. He maintained a gun collection and used beer cans labeled with the names of colleagues who had displeased him for target practice. He once brought an actual axe to the office and announced he would use it to chop through bureaucratic red tape. An interviewer who visited his apartment reported that it contained no food whatsoever, only alcohol and glassware. but his circuit designs operated at a level that made the rest of the industry seem years behind. At National, Widlar created the LM101, the first operational amplifier using single capacitor frequency compensation, a breakthrough that made precision analog design accessible to a generation of engineers who had never attempted it before. He followed it with the LM101A, an improved version with FET current control. He designed the LM108, a super beta op-amp with input bias currents so small they seem to violate the known physics of bipolar transistors. And he created the LM109, the first monolithic integrated voltage regulator, which eliminated the need for external pass transistors in power supply circuits entirely. Each chip became the standard in its class. Each one made National Semiconductor the company that serious analog engineers ordered from first, before they looked at anyone else. Then, on December 21, 1970, at approximately 10:30 in the morning Pacific Time, Bob Widlar retired from National Semiconductor. He was 33 years old. He drove his 1966 Mercedes 280SL convertible south from Santa Clara to Puerto Vallarta, Mexico, and disappeared from the industry. The most celebrated analog designer alive had simply decided he was finished. Sporck, meanwhile, was prosecuting what the semiconductor industry would remember as the Great Price War. He began slashing the prices of standard semiconductors, undercutting competitors on logic chips, voltage regulators, and op-amps with a ferocity that stunned the industry. The strategy was methodical and merciless. Produce in enormous volume, cut manufacturing costs to the absolute minimum, open assembly and test plants in Malaysia, Singapore, and across Southeast Asia, where labor was a fraction of American wages, and force any competitor who could not match the price to exit the market entirely. National Semiconductor was among the very first American chip companies to offshore its final manufacturing operations, and Sporck pushed that model harder than anyone. His philosophy was not about designing something no one else could build. It was about building what everyone needed, cheaper than anyone else could build it. Improve the process, standardize the output, eliminate waste, ship volume. It worked with devastating efficiency. The price of a standard TTL logic gate dropped from several dollars to under $1 and then kept falling. Companies that had entered semiconductors as a sideline discovered that their chip divisions were now losing money against National's relentless undercutting. General Electric, one of the largest industrial corporations on Earth, left the semiconductor business. Westinghouse, its chief rival, left the semiconductor business. A dozen smaller firms either merged into larger competitors or folded outright. By the early 70s, the number of American semiconductor manufacturers had contracted sharply, and National was one of the survivors standing in the cleared field. National Semiconductor earned a reputation, in the words of a competing executive quoted in Fortune magazine, as the sweatshop of the industry, a pipe rack, low-cost, survival-oriented company. Sporck took that characterization as a compliment. By the mid-1970s, National's annual revenues had reached $365 million. Sporck, emboldened, pushed into the computer mainframe market, betting that a chipmaker could build complete computing systems. He also diversified into point-of-sale equipment, checkout systems, and consumer products, including digital watches, a venture that proved how quickly a cost-driven company could lose money in a market that demanded fashion. By 1986, only 53% of National's revenue came from semiconductors, and the company was manufacturing products across a range that would have been unrecognizable to its founders. The mainframes were ambitious, but ultimately peripheral. The core of National's identity and the source of its staying power remained what it had always been: analog circuits. In 1976, Bob Dobkin, one of National's senior linear design engineers, created the LM317, a 3-terminal adjustable voltage regulator. 3 pins: input, output, adjust. 2 external resistors set any desired output voltage between 1.25 and 37 volts. The device delivered 1.5 amps of current with built-in thermal overload protection, current limiting, and safe area compensation, all fabricated on a single piece of silicon the size of a fingernail. The LM317 was not glamorous. It did not generate press coverage or boardroom excitement. What it did was become one of the most manufactured integrated circuits in the entire history of electronics. Every hobbyist who ever built a bench power supply soldered one onto a board. Every engineering student in every circuits lab course in every university held one between their fingers. It cost pennies. It worked for decades without failure. It shipped in quantities measured in the hundreds of millions. Bob Pease, another national engineer who had joined the company that same year after spending 15 years designing op amps at Philbrick Researches in Boston, created the LM337, the negative voltage complement to Dobkin's design. Together, the pair could regulate virtually any DC power supply a working engineer was likely to build. The following year, National released the LM386, a low-voltage audio power amplifier in an 8-pin DIP package that ran off a 9-volt battery. It drove a small speaker with a 1/4 watt of clean output power. It required fewer than 10 external components. The LM386 was designed for portable radios, intercoms, and educational kits, but it escaped its intended market almost immediately. Hobbyists put it in guitar amplifiers, amateur radio transceivers, signal tracers, burglar alarms, and projects that no product manager at National had ever imagined. The Smoky Amp, a guitar amplifier small enough to fit inside a cigarette pack, was built around a single LM386. In some engineering programs, the chip earned the nickname the student's hi-fi chip because it let a beginner build something that actually produced sound from a handful of passive components and a speaker. More than 4 decades after its introduction, the LM386 remains in continuous production. Texas Instruments manufactures the official version. Unisonic Technologies and several other Asian firms produce clones. Hobbyists still argue about their relative merits on electronics forums. The company that designed the original is gone. In 1981, National Semiconductor became the first semiconductor company in the world to cross $1 billion in annual sales. Revenue reached $1.1 billion, tripling in 4 years. The company employed 40,000 workers, 2/3 of them in Southeast Asian assembly and test plants that Sporck had pioneered as the cornerstone of his cost model. National's catalog listed more than 5,000 distinct chip types, spanning analog, digital logic, military-grade components, and emerging microprocessor families. The company's stock was trading on the New York Stock Exchange. Its Santa Clara campus sprawled across multiple buildings, and its name appeared in the purchasing specifications of every major electronics manufacturer from Tokyo to Munich. On August 5, 1986, National Semiconductor became the 20th company in the world to register an internet domain name, nsc.com, a detail that says more about the company's place in the technology hierarchy of the era than any revenue figure could. Gordon Moore, speaking at Sporck's retirement dinner years later, compared him to Johnny Appleseed, except that where Appleseed planted trees, Charlie Sporck built fabs. He built them everywhere, and he ran them better than anyone. But 1981 was also the year the fractures appeared. 5 key executives left National for better-paying positions, among them Pierre Lamond, the company's most gifted technical mind. National had never led the industry through invention. It led through cost discipline and manufacturing volume. Its chips were reliable, plentiful, and cheap. They were also straightforward to copy, and by the early 80s, Japanese semiconductor manufacturers were doing exactly that, producing equivalent analog and logic devices at comparable quality and lower prices. The competitive moat that Sporck had spent 15 years digging was being crossed by companies that had studied his methods and executed them with even greater precision. The company tried to diversify forward, and for a brief window, it looked like it might succeed. The NS32000, a 32-bit microprocessor family, shipped in 1984, a full 6 months before any competitor had a commercially available 32-bit processor. Engineers praised its architecture. Early sales were strong, but the IBM PC had already crowned Intel's x86 instruction set as the industry standard, and no amount of architectural elegance could overcome the gravity of an installed base that was doubling every year. National's microprocessor never found its ecosystem. Meanwhile, the mainframe business, which Sporck had entered in the late 70s with the System 200 and System 400 lines, was hemorrhaging cash. IBM cut prices aggressively, and National's computer customers either defected or went bankrupt. The company had also tried its hand at point-of-sale terminals and consumer electronics, including an ill-fated venture into digital watches that lost money before being abandoned. By the late 80s, Sporck and Sprague were cutting the failed diversifications away with increasing urgency. Data Checker, the point-of-sale division, was sold. The mainframe lines were shut down. The lesson was expensive. National Semiconductor was very good at making chips and terrible at making the products those chips went into. In 1987, National acquired Fairchild Semiconductor from Schlumberger for approximately $122 million, gaining MOS technology and additional fab capacity, but also inheriting a company that carried its own structural burdens. Robert Noyce died on June 3, 1990, at the age of 62. Sporck said later that Noyce's death caused him to rethink his own direction. In early 1991, Charlie Sporck retired as CEO of National Semiconductor after 24 consecutive years. He was 63 years old. Bob Widlar, who had returned quietly from Mexico in the mid-70s and designed the LM10 and LM11 for National on a contract basis, died in Puerto Vallarta on February 27, 1991. He was 53, heart failure, alone and far from the valley that remembered him as a legend. He left behind a body of work that had defined the analog integrated circuit as a discipline, and a personal mythology that no one who worked alongside him would ever stop repeating. Gilbert Amelio, a physicist with a doctorate from Georgia Tech, who had led Rockwell International's semiconductor division, took the CEO role. He inherited a company burdened by excess manufacturing capacity and shrinking market share, despite having invested more than $1 billion in research and development over the preceding 5 years. Amelio reorganized National aggressively, splitting the product catalog into 2 tracks. The first was commodity chips, the low-margin logic and memory devices, on which National had built its reputation. The second was higher-margin analog and mixed-signal circuits, which were harder to copy and commanded better prices. The restructuring worked, at least on paper. Record net revenues of $2.29 billion arrived in 1994. But Amelio's attention was already drifting toward Cupertino. He joined the Apple Computer Board in 1994. By February 1996, he had resigned from every leadership role at National Semiconductor to become Apple's CEO, attempting yet another corporate turnaround. He lasted 17 months at Apple before Steve Jobs replaced him. The pattern was unmistakable. National Semiconductor had become a stepping stone. Brian Halla, a veteran of 14 years at Intel's marketing division and a former executive at LSI Logic, assumed command in May 1996. His first significant act was to consolidate National's commodity chip lines into a new entity under the resurrected Fairchild Semiconductor name. In March 1997, National sold this reconstituted Fairchild to an investment group led by Citicorp Venture Capital for $550 million. That same year, Halla spent $540 million to acquire Cyrix Corporation, a Texas-based maker of budget Intel-compatible processors, betting on a system-on-a-chip strategy for sub-$400 PCs. Intel responded by cutting Celeron prices with a ferocity that mirrored Sporck's own price wars of the 1960s. In the fourth quarter of 1998, Cyrix had shipped more than 3.5 million processor units. By the first quarter of 1999, that number had dropped to 1.55 million. The average selling price per chip fell below $50 and kept falling toward $42. Cyrix's U.S. retail market share collapsed from 22% in November 1998 to roughly 5% by March 1999. National tried to find a buyer for the Cyrix operation, but announced the exit from PC processors before any deal was finalized. VIA Technologies of Taiwan eventually acquired the Cyrix brand and design team. National also attempted to sell its new fabrication plant in South Portland, Maine, which had been built partly to manufacture Cyrix processors. The loss was staggering, both in dollars and in credibility. What remained after the Cyrix debacle was, in an almost poetic way, a return to the company's original identity. HALA stripped National down to its analog core: power management ICs, display drivers, operational amplifiers, data converters, audio amplifiers, communication interface chips, the exact categories of devices that Widlar and Dobkin and Pease had spent their careers designing and refining. Revenue stabilized, margins improved. The company was profitable again. But it was a fraction of its former scale. By 2010, National Semiconductor employed 5,800 people, down from 40,000 at its peak, and reported annual revenues of $1.42 billion. On April 4, 2011, Texas Instruments announced it would acquire National Semiconductor for $25 per share in an all-cash transaction valued at $6.5 billion. The offer represented a 78% premium over the previous day's closing price of $14.07. National's shareholders approved the merger in June. On September 23, 2011, the deal closed. National's portfolio of 12,000 analog products was folded into Texas Instruments' catalog, creating a combined inventory of nearly 45,000 devices. The ticker symbol NSM went dark forever. Bob Pease did not live to see the final day. The man who had joined National Semiconductor in 1976, who had never left, who had designed the LM331 voltage-to-frequency converter and the LM337 negative voltage regulator, who had anointed himself the czar of band gaps and worn a quasi-military uniform with a necklace made from metal TO3 transistor packages to prove it, was killed on June 18, 2011. His 1969 Volkswagen Beetle missed a curve on a steep road outside Saratoga, California. He was 70 years old. He had been driving home from a memorial service for Jim Williams, an analog circuit designer at Linear Technology. The company founded in 1981 by Robert Swanson, Bob Dobkin, and Bob Widlar himself, all formerly of National Semiconductor. Pease had driven to the memorial directly from his office at National. It was a Saturday. He was still working. He was still designing analog circuits for a company that would not exist in 3 months. The irony runs deeper than any single loss. Linear Technology, the company that National's own engineers founded after walking out the door, grew into one of the most consistently profitable analog chip makers on the planet, posting operating margins that made the rest of the industry look careless. Analog Devices acquired it in 2017 for $14.8 billion, more than double what Texas Instruments paid for all of National Semiconductor 6 years earlier. Don Valentine, hired from Fairchild alongside Sporck in 1967, left National in 1972 and founded Sequoia Capital, the venture firm that went on to seed Apple, Cisco, Google, WhatsApp, YouTube, and dozens of other companies whose combined market capitalization dwarfs anything the semiconductor industry itself has ever produced. Floyd Kavama, another Sporck recruit, later became a partner at Kleiner Perkins, the other great Silicon Valley venture fund. The talent that passed through National Semiconductor's doors generated more value after leaving than the company ever captured while it housed them. National did not merely contribute to Silicon Valley, it trained the people who built it and funded it. Charlie Sporck spent his retirement summers in Saranac Lake, New York, the village where he had grown up, where the air smelled like pine and the Saranac River ran past the same houses it had run past when he was a boy. He built the Caroline Sporck Admissions Building at nearby Paul Smith's College, the school where he had once studied for a semester before transferring to Cornell. He donated to the Riverwalk and the Adirondack Hospital. He was known for his cigars, his common sense, and his absolute refusal to sentimentalize the industry he had helped create. In 2001, he published a memoir titled Spin-Off, a personal history of the industry that changed the world. On October 12, 2024, Charles Edward Sporck died in Sunnyvale, California, at the age of 96. The New York Times called him a founding father of Silicon Valley. He was predeceased by his wife Janine and both of his sons. Today, if you open a parts drawer in any electronics laboratory in the world, you will almost certainly find an LM317 voltage regulator. 3 pins in a TO220 package, a small metal tab, with a hole for a heatsink bolt. The package weighs about 2 grams. It fits between your thumb and forefinger. The datasheet says Texas Instruments across the top in the same place where National Semiconductor's logo used to be. The part number still carries the LM prefix that National assigned to every one of its linear monolithic designs, a naming convention that dates back to Bob Widlar's earliest work in the late 1960s. The circuit inside the LM317 is functionally identical to the one Bob Dobkin laid out in 1976, almost 50 years ago. It still regulates voltage. It still protects itself from thermal overload. It still costs less than $1. You can buy a bag of 10 from any electronics distributor for the price of a cup of coffee. The company that created it no longer exists. The chip does not care. National Semiconductor invented the analog building blocks that power every electronic device on the planet. It built them cheap, it built them everywhere, and it built them to last forever. The chips outlived the company. And that was the whole story. If you ever built a circuit with an LM317, or soldered an LM386 into a breadboard, or spent a long night debugging a power supply with a National Semiconductor datasheet open on your bench, drop a comment below. Tell us the part number, the year, and whether it still works. The people who used these chips and the engineers who designed them know more about what was lost than the people who sold it. Subscribe to Tech District so you do not miss what comes next. We have the story of another American semiconductor empire, and you will not want to miss how it ends. If the channel is new to you, it is called Tech District.